Part 4 of question number 21. So now we are in the last part of this question. Actually, as I already mentioned earlier, please kindly see the previous 3 parts because this question has 4 subdivisions. In the first part of the video, I solved the question for part A, B and C. And then in the second part, I solved the question from D to G. That means D, E, F and G. And then the third part of the video, I solved the question H, I, J and K. Now in the last part, we are going to solve the question from L, M, N and O. Right? So please see the previous 3 videos. So then only you can understand the clear picture about this question number 21. Right? Okay. So now in this part, what we are going to do, we are going to consider the path from point 3 to 1. So you can see from the figure, from point 3 to 1, it refers to adiabatic. And for this adiabatic path, we are going to find the answer for L, M and NO. Clear? So, okay. So anyhow, we can write the given one more time. As they already mentioned in the question, this is the diatomic gas. What is diatomic gas? So for diatomic gas, the CV value is 5 over 2 times of R and CP value is 7 over 2 times of R. So by using the CP and CV, we can find the value for gamma. So gamma is equal to CP over CV. So by that we will get 7 over 2 times of R over 5 over 2 times of R. We can cancel these 2 and R. By that we will get the value of gamma, which is 7 over 5, which is equal to 1.4. And also from the PV diagram, the value at point, the volume value at point 1, let's take 1 and then V 2 and 3. That means point 2 and 3 will take the answer for value of 4 times of V1. Clear? So we have to substitute this value. So you can see here in part 3 to 1, we are going to consider the adiabatic curve. So when you come for adiabatic, we must need the value for gamma. Clear? So we are going to solve one by one. So let's start with the question L. What is given in question L? W over nRT. In question number L, we are going to find W over nRT. Clear? And what path we are going to consider? From path 3 to path 1. And this path 3 to 1 refers to adiabatic. What is adiabatic refers to? Q equal to 0. There is no heat flow. Now, if you take the first law of thermodynamics, Q which is equal to change in internal energy plus work done. So therefore, if you substitute Q equal to 0, you will get the work done which is equal to negative of change in internal energy. Right? So now what I'm going to do, for getting this answer of W over nRT, I'm going to use this part. So W equal to minus of change in internal energy. So what is the formula for internal energy? Which is minus of NCV delta T. And here delta T is nothing but, because we are going to consider path 3 to 1. So that means here delta T we can write as NCV, final temperature T3 and initial temperature T1. Clear? And now we have to substitute the value for CV. For CV, which is N times, because this is number of moles, and CV is nothing but 5 over 2 times R. So T3 minus T1. Now what I'm going to do, we can substitute, we can use the relation. So let's just go back to the diagram, the figure. Point 3 to 1, we are going to study the relation between temperature and volume. Right? So what's the relation for temperature and volume? The relation for temperature and volume is TB gamma minus 1, which is equal to constant. So I have to substitute the value for T3 from this equation. So what I'm going to do, I'm going to use this relation for the point 3 and 1. So by that we will get T3 V3 gamma minus 1, which is equal to T1 V1 gamma minus 1. We are going to find the answer for T3. Clear? So I have to rearrange in terms of T3. So I can move this V3 of gamma minus 1 power to the right hand side of the denominator. By that we will get T3 equal to T1 V1 gamma minus 1 over V3 gamma minus 1. We can write these as T3 equal to T1 V1 over V3 power of gamma minus 1. Now I'm going to substitute this T3 here. If you take this T3 and substitute here, we will get to the left hand side. The left hand side we got W. So right hand side we will get minus of 5 over 2 times of N R. So inside the bracket I'm going to substitute T1 V1 over V3 over gamma minus 1 minus T1. Now you can see T1 common term, we can take it outside. Therefore W, which is equal to minus this 5 over 2 is nothing but it's 2.5, right? 2.5 and NR, and we can take T1 as a common term. So what is inside the bracket? V1 over V3 power gamma minus 1 minus 1. As we already know, gamma, which is equal to 1.4, right? So 1.4 minus 1, which is equal to 0.4. So now we are going to find the answer for W over N or T1. So we can take this term to the left hand side of the denominator. By that, this becomes W over N or T1, which is equal to minus 2.5. And the value of V1 is 1 and V of 2, 3, which is equal to 4 times of V1. So V1 takes the 1 and V3 takes 4. And 1.4 minus 1 is 0.4 minus 1. So now we will get the answer for the right hand side as W over N or T1, which is equal to minus 1.06. This is the answer for the question L. Clear? Now we have to come for the question M part, the second question of this fourth part, right? So your second question is M, right? So what they ask in question M, let's we go back to the question. In M part, we are going to find Q over N or T1. So Q over N or T1 we have to find in question M. So Q over N or T1 we are going to find for the path 3 to 1, which refers to adiabatic. What is adiabatic? Q equal to 0. So here we are going to find Q over nRT. So the Q is already equal to 0, right? So that means the answer for this question, Q over N or T1, which is also equal to 0. Clear? Now we have to come for N part. So in N part, we are going to find change in internal energy over N or T1. We have to find for the path 3 to 1, which refers to adiabatic. What is adiabatic? Q equal to 0. So let's take the first law of thermodynamics. So Q, which is equal to change in internal energy plus work done. If Q equal to 0, your work done or your internal energy, your change in internal energy is equal to negative of work done. Am I right? Now you can see this negative of work done for path 3 to 1. We already got the answer for in the question number. What is the question number first one? L part. So work done, we already got the answer here as W over N or T1, which is equal to minus 1.06. So we can take this value here because both paths are same. So W from question number L, right? In question number L, we got the answer W over N or T1, which is equal to, so the answer here we got as minus 1.06. From this we can take W. So W, which is equal to minus 1.06 N or T1. So what I am going to do from part L, from the answer, I am going to take this answer and I am going to substitute here. So if you substitute, what you will get, change in internal energy, right, which is equal to negative, already we have. So what done here is negative of 1.06 N or T1, right? So here minus into minus become plus. So therefore, your change in internal energy equal to 1.06 N or T1. So we can move this N or T1 to the left hand side. So therefore, your change in internal energy over N or T1, which is equal to 1.06. So this is the answer for part N. The last part, we come to the last part of this question, which is O, right? What is O? We are going to find delta S over NR. As we already going to the part 3, 2, 1, which refers to adiabatic, right? So for delta change, so that means the change in entropy, delta S, which is given by N or natural log of V final over V initial, right, plus NCV natural log of T final over T initial. So this rule we have to use here. Clear? So let's we take this rule, and in place of final and initial, I have to substitute final place. I have to substitute 3 because we are going to consider the point 3 to 1. So I have to use this number here. So delta S, which is equal to N or natural log of V3 over V1, right, plus N, and then CV 5 over 2 times of R, right, natural log of T3 over T1. Now you can, we already have the value for V1, V2 and V3. So here N or natural log of V3 takes the value of 4 over 1 from the PV diagram, plus 5 over 2 times of N or natural log of T3 over T1. Now you can see in this first part and the second part, the term NR is a common term, so we can take it outside. Therefore, NR, which is equal to natural log of 4 plus 5 over 2 times is 2.5, right? 2.5 times of natural log of T3 over T1. Now, in this part, we have to apply the rule for the relation between the temperature and the volume. The relation between temperature and the volume, TV gamma minus 1, which is equal to constant. So if you apply this rule for point 3 and point 1, we can write T3 V3 gamma minus 1, which is equal to T1 V1 gamma minus 1. So from this we can write this term as T3, which is T1 V1 over V3 the whole power gamma minus 1. So now what I'm going to do, I'm going to take this T3, I have to substitute here. If you substitute, before we substitute, let's we take NR to the left hand side. By that we will get the answer for this question, because the question itself they mentioned delta S over NR. So I can move this NR to the left hand side of the denominator. So therefore left hand side equation delta S over NR, which is equal to natural log of 4 plus 2.5 natural log of, in place of T3 I have to substitute that value, which is V1. So T1 V1 over V3 gamma minus 1 over T1. So T1 get cancelled here. So the remaining terms are delta S over NR equal to the natural log of 4 is 1.39 plus 2.5 natural log of 1 4. The gamma value is 1.4 minus 1. So this term becomes delta S over NR equal to 1.39 plus 2.5 natural log of 1 over 4 power 0.4. So here, when you use your calculator, this part, you get delta S over NR. This is 1.39 for the first part of this, plus when you use your calculator for this part, you'll get minus of 1.39. So plus 1.39 minus 1.39, because plus into minus become minus, so you'll get 1.39 minus 1.39. We will get the answer for the last part of this question, delta S over NR, which is equal to 0. Clear? So this is the answer for this question. So kindly, if you want to go through this question, kindly see the previous 3 parts, because as I already mentioned, we have 15 questions in this question number 21. Clear? So that's it. Thank you.